c'est aussi un plaisir de travailler avec nos collègues brésiliens. So, please welcome Dr. Mario Soares. Mario est professeur à l'Université Estado de Rio de Janeiro. Il dirige le groupe de recherche sur les mangroves. Il est membre du comité brésilien sur les zones humides et de l'Observatoire international sur le changement climatique. Please, Mario, if you want to falar português. No, you want to speak English? Français? 20 minutes.
Not French. Good afternoon. I have a challenge to be the last talk before the cocktail. I would like to thank the organizer, to thank Christophe, Antoine, Siva staff. So when you talk about the impacts of climate change on mangroves, we must consider several possible impacts. However, in my talk today, I focus on two of them, the sea level rise and change in rainfall regime. I will talk, first of all, about mangroves' response to sea level rise and the effects of climate variability on mangroves. Then highlight the complexity of mangrove response to climate change. And finally, try to bring some contributions to the civil discussions here in the meeting. Although we carry out some studies on the Brazilian equatorial coast, this is all the sites we study along the Brazilian coast, our studies on the response of mangroves to climate change and variability are mainly located in the south coast and southeast coast of the Brazil, mainly in Rio de Janeiro state. So I will focus my presentation on the results of our studies in mangroves in this state, more specifically in Guaratiba Biological Reserve, where we can find two features associated to the mangrove ecosystem, the forest, the mangrove forest, and the salt flats, okay? And when we first described this forest some years ago, we described it as a classical zonation pattern associated with the increase of salinity landward, because we are under climate with seasonality, dry season in some times of the year, and associated with the tidal fluid decrease landward, we have the increase of the salinity. The salinity goes from 30 parts per thousand to above 100 parts per thousand in the salt flat. And associated with this gradient, we have also a gradient of forest development that decrease towards the fringe, from the fringe to the transition to the salt flat, and also change in mangrove species composition. In the fringe mangrove, we have the presence and the domination of Rhizophora mangli, and in the transition and in the base mangrove, we found Avicennia shaweriana and Laguncularia racemosa. So it's a classical pattern of mangrove zonation we're observing in several places of the Brazilian coast. However, oops, it's not working. No.
Beatrice?
I hope yes. No. Beatrice? Let me try here. Yeah. Okay. However, in 1998, we observed an event of colonization of the Salt Flat by mangrove species. And we started monitoring this new community by the establishment of juxtaposed plots where all the individuals were tagged and measured, okay? And with each new visit, when a new colonization event was detected, new plots were delimited along these 25 years. Then the simple establishment of new plots each year already represents or indicates a process of forced migration over the Salt Flat. For example, in 1998, we established 6 plots, and now we have about 20 plots, which represents this migration of the mangroves through or over the Salt Flat. Based in the conceptual model we had been working since the 90s, I will not explain this model. Basically, what we present here is that if you have available area behind the mangrove and the sea level rise, you have the possibility of the mangrove to adapt and migrate over the Salt Flat. So we predicted with this model that the Salt Flat would transform into a mangrove forest. And our results, when compared with Jimenez, for example, model and also the Duke model for mangrove development, confirmed that a long-term process of landward mangrove forest migration is occurring. Even, if you observe here, even the structure of the former forest initially described as a simple zonation pattern reflects the succession process. For example, the fringe forest and the base forest. Each one of the zones represent different stages of mangrove or forest development. For example, if we go here, the youngest colonization community is in the beginning of the early colonization phase. And as we come to the oldest or the first colonization community, we can observe that this community is in the early development phase. And in the former forest established there, the basin forest in the end of the early development phase. And finally, the fringe forest is in the maturity stage. So we have a process that are occurring for a long term along this gradient from the fringe mangrove to the Salt Flat. Only to illustrate some of this process, we have here in 1999, so the colonization community with 1 year old, a student in the plot, the oldest plot. In 2001, the same student. 2004, I changed the student, a taller one with the hand up. And since 2009, we are still looking for the student, okay? And three weeks ago, I take this picture with the 25 years old forest in the same place. So let me back. This is the scenario in 1999, and this is 25 years old forest 2 weeks ago. So the colonization of the Salt Flat by mangrove species indicates a change of the conditions, the harsh conditions in the Salt Flat, will be modified probably by the increase of the frequency of sea level, the frequency of tide inundation induced by sea level rise. So these results are in agreement with the model I showed you, and also with the observations of sea level that we have for the Southeast Brazil and present by many studies of the colleagues from the Brazil. I would like to go back to this picture to show that if we look from the Salt Flat to the forest, we can observe here different levels in the forest, different steps. We have the first one, the first step, that is the colonization, the first colonization in 1998, and the other 4 steps along the mangrove forest. So it indicates that we have a colonization process that occurs in pulses, not in a continual process, but we have moments of colonization. And based on this figure, we began to investigate what process are being determining this pattern of post-colonization of the South Flats. For that, he used some tools, phytosociology, dendrochronology, climatology, remote sense, and also the analysis of time series. When you look here for the water balance, compare the water balance, that is the figure in the top, with the sapling growth, we can observe that the green area represents the water storage in the soil. The red area represents water deficit, and the blue area represents water excess. So we observe that during periods of low water storage in the soil, there's a reduction, what's expected, reduction in the growth of the mangrove saplings, for example, in periods 2 and 4. And on the other hand, in periods of excess of water and water storage in the soil, you observe the greater growth of mangrove saplings. So we have moments of high growth and moments that the growth is low. So we also perform an evaluate analysis applied for this time series for mangroves, or for the climate data in Guaratiba. So we observed, for example, cycles of around 6 years, which are compatible with periods in agreement with periods of some indices related to El Nino. And this data is also in agreement with the analysis we did in growth ring by dendrochronology, comparing the difference between the mangrove basin and the transition mangrove forest with the South Flat. Otherwise, we also make some analysis about based in remote sensing, where we compared the mainland mangroves, the cover of forest of mangroves in the mainland, which has as a source of water the continental freshwater and the rainwater, and the Berry Island mangroves in Marambaia, Berry Island, that have the only source of water based in rain. So it's the first analysis we did. Now we are updating this analysis, and we compared 3 periods, 3 images, I'm sorry, 1984, 1994, and 1994 with 2003. What we see here is that in dark green are areas that remained as mangrove forests throughout the period. So there is no change in these areas. In yellow are areas that remained as salt flats throughout the period. In light green are areas that was in the first image salt flats and became colonized by mangroves, and in orange areas that was mangrove and became salt flats. So what we observe here is that in the first 10 years, we have a retreat of mangrove forests and expansion of salt flats. And it's the last 10 years, we observed the recovery of the mangrove forest and the retreat of salt flats. So we have the mangrove pulsing throughout these 20 years. So they expand and then retreat, they expand and then retreat. And we observe the water balance of the same period. We can observe that in the first 10 years, there is higher occurrence of periods with water deficit, and events represent a water deficit are less frequent and less intense in the last 10 years. So it's in agreement with the behavior of expansion and retraction of the mangrove forest. When we perform the same analysis in a 3 years basis period, we can observe this alternation of behavior in the Marambaia Berry Island, where there is only the source of water, the freshwater source is only the rain. However, we don't observe this process in the mainland mangrove, where the expansion of the mangrove is constant throughout the period, basically, in response to sea level rise, okay? So we can propose that the response of mangroves to sea level rise also depends on the variability, the climate variability and availability of water. For example, if you are in a freshwater, in a mangrove with freshwater input, We also observed expansion of mangrove forests and retreat of salt flats. However, this rate will be slow in the dry periods and will be faster in the wet period. On the other hand, in areas without freshwater inputs, as for example, the Barrier Island we studied in Rio de Janeiro, there will be an expansion of the mangroves as a response to sea level rise in the wet period in a slow rate. However, in the dry period, there will be a retreat. So what we can observe is that there is a complexity and in this process, with a process of sea level rise and also a variability of climate, availability of water associated climate variability, okay? So, bringing some contributions to the CBA based in our studies in Rio de Janeiro, one of the aspects we observed is that the mangrove response to climate change is highly associated with the dynamics of these mangroves. However, these dynamics depend in many other responses of the mangrove to climate change. For example, changes in phenology, biomass, respiration, species competition, and so on. These dynamics involves understand the patterns and process related to the species physiological requirements and interactions. Therefore, one of the challenges is to understand for each mangrove forest, what are the factors, what are the drivers that control these dynamics and how they are affected by climate change. For example, in Rio, as we saw in our studies in Rio de Janeiro, the dynamics of this forest is clearly responding to the models of forest development and gap dynamics proposed both by Jimenez and Duque. And what we can see in Rio is that the process, the dynamics of the mangrove forest dynamics depends and responds to sea level rise that affect the tidal inundation, affect the salinity patterns, but also the climate variability study is interesting to understand the changes in the rainfall and water balance, water availability in the future. So what we have is the process and the cycles. And also we have to consider the biological interactions between the mangrove species, competition, tolerance to difference in salinity, and so on. When we go to the region under the influence of the Amazon River, such as, for example, French Guiana, as we saw in the other presentations, we have to consider the dynamics of the mudbanks, not only the dynamics of the mangrove forest itself. Also, we have to consider that, but we have a driver that is very powerful, that is the sedimentological dynamics. So I would like to highlight this model that was proposed by Froment, which seeks to explain these dynamics, considering 3 levels. The first 2 levels is the same we consider and we have observed in Rio de Janeiro, that concerns to the forest development and forest dynamics, gap dynamics, regeneration. However, they present a sedimentological process as a 3rd level that must be considered in this process of response to climate change for mangroves in this area. What it says that we do not have to forget the forest dynamics, the development of the forest in different phases, from colonization to maturity, but we have and we must to consider also the sedimentological dynamics represented by the mudbanks. So what you can see is something like that we have the mangrove dynamics, we have this mudbank dynamics that control the mangroves dynamics. And what are the drivers? The drivers here are different from the drivers we observe in Southwest Brazil. We have other drivers that must be considered And this driver includes teleconnections process and cycles. For example, Atlantic dipole, the difference between the temperature of the North and the South Atlantic that influence the trade winds, the intertropical convergence zone, the ENSO, the El Nino, but also we have to consider what happens in the response of the Amazon basin to this climate change also, because it's the source of the sediments. And in the Amazon basin, we must also consider other human activities, for example, deforestation. So we have many drivers that must be considered, and it's an example of the complexity of this process and the difference between different mangroves from the Southeast Latin America, for example, in Rio de Janeiro, and the equatorial process we observe here in French Guiana. So only for an exercise, if we consider the present mudbanks dynamics, that is the line in the middle, and consider the change in these drivers, intensity or frequency that will influence the time life or the presence of the mudbanks that could increase or decrease, we must have a change in the maximum potential biomass of these mangroves, because we have more time or not for the development of mangrove forests. And it could or should have potential effects of many services of these ecosystems: coastal protection, biodiversity, carbon stock production, and outwelling of organic matter. So it's a supposition. If we don't know what will happen, it's my question for you here. So it's only to illustrate the complexity and the variability of mangrove response in different areas from the same continent, for example, South America, under different drivers, and the challenge we have to understand and to manage this process and the conservation of these ecosystems. Thank you. Merci. This is a French mangrove and salt flat, New Caledonia.
Obrigado, Mario. Thank you for the very good presentation and for the effort to share data on Rio de Janeiro and try to make the comparison with the French Guiana. One point I would like to highlight is the extraordinary capability of a few mangrove species to adapt to a range of very distinct, different geomorphic settings and climate conditions. So it's something we have to keep in mind. With a few species, we can adapt to a large range of conditions in the earth. If you have any question, please. Do not be so shy.
Here.
Thank you, Mario, for that very nice talk. Did you have a look at the back mangrove area as well? Because the accommodation space you've got with sea level rise in your study sites, because I think that's quite important as well. And
yeah.
Actually, what your study shows the adaptability of mangroves. I mean, we as humans, we can flee problems by moving away, but mangroves do the same thing in the long run. I mean, they migrate.
That is one of several of the slides I cut off the presentation because of the time. But we are concluding right now a study where we measured the area available, mapping the human occupation, the geomorphology, because it's not only human occupation. We have in some place of Rio de Janeiro. I mean, talk about Rio de Janeiro state, and some place like the south region of the Rio de Janeiro state, we have a mountain. So we don't have coastal plains available for mangrove. In other areas, we have human occupation. So we quantified this area and made some projections with the scenarios of sea level rise. It measures the proportion of the mangrove, the present today, that will be remain under these scenarios. And also we crossed with the rate of dependence of the fishermen to have idea of the social resilience also. So it's just been concluded, this project in Rio.
So do you have urban squeeze on mangroves in
Yeah,
large areas?
Yeah, we don't have data about that in Rio, but we have that.
Yeah. Florianopolis, for instance,
Yeah,
got mangrove squeeze.
Any further comment, question? Oh, Gwenaël and then Grégoire.
Thank you, Mario, for the very nice presentation. And I think it's just amazing to see the differences between the systems, the one Edouard described and the one you have described. And also the driving forces on the mangrove are totally different. Edouard was talking about increase in wave energy, and you are talking about sea level rise and hydric budget of the mangroves. So I'm just wondering how we could, in the future, put some order, classify something to get a better understanding of the future of all types of mangrove. If we had, for example, the case of carbonate mangrove, there is one of our colleagues is working on a carbonate mangrove in New Caledonia. And what's happening there is the sea level rise. That is, I would say, the respiration of the soil is increasing, and this is dissolving the carbonate substrate below. So this is another type of response. Mm-hmm. So what do you think about trying to put some order in all of this complexity?
Yeah. For example, in the model I present, but not detailed, we included another parameter based on the behavior of the mangroves during the Holocene. That is the rate of sea level increase. The rate of sea level increase must be compatible with the life cycle, because if the sea level rise fastly, the mangrove don't have time to adapt and to migrate. They should disappear. So the challenge is big because we have the same ecosystem with variability of factors control the drivers. And I think that one way is to maintain these long-term studies as we have in Rio, as we have here in French Guiana, to understand, but also you have to understand the variability of systems, geomorphological systems in different latitudes, in different regions, because one thing is, as Christophe said, one thing is the behavior of the mangrove in America, where we have, for example, in Brazil, 6 species. Other thing is the same process in a system that we have 40 species, other biological interactions also. So it's very big, the challenge. We are beginning to understand one patch of mangrove in Rio de Janeiro biological reserve is about 4,000 hectares. It's very small. It's when compared to North Brazil, French Guiana.
Maybe that's why we must try to think to a regional observatory all along the South America coast on mangroves.
It's a way, an observatory with many institutions
It's possible.
The same protocol.
Mhm.
It's important.
Yeah.
Have to study the same way.
So I would like to thank you, Mario.